Hello, my friends. I'm recording this on your snow day. The lighting is terrible in here, so I apologize. I know that you're very concerned about it. We're taking some split notes today, so here is unfortunate news. I was unable to give everyone a hard copy of these notes on Monday, today, but you have the digital copy in there, so as you watch this video, please fill in the notes. Guys, please, okay? It's not about the work, it's about the process. I'm not going to sit here and lecture for 25 minutes. The goal is under 10 minutes, knock on wood. But we were talking about kind of how and why the periodic table is organized the way it is. Think back, you did your alien sort. We've sort of been studying, well, not sort of, but we've been studying the periodic table for the last couple days. We're going to kind of get into why these things are in each group, each period, why they are arranged. Why is copper, gold, and silver stacked up on top of each other? What properties do those things have? So what I would like you guys to have out, you have your notes, either printed them out, go ahead and print them out. I like mine printed out. I like to do hard copy. If you have them up on your computer, I also, guys, you should have out your periodic table because that's kind of our roadmap. All right, so again, please watch the video. I'm not going to ramble forever, I swear. We're talking about why everything is organized the way it is, the three types of elements on the periodic table: metals, nonmetals, and metalloids. Watch, and let's go. All right, as always with split notes, okay, we know that if it's in a different color, please fill it in. Make sure you're filling along with it. All right, so periodic table basics. We know it's organized, okay? It's organized into rows and columns. And what we're going to talk about today is what those rows and columns actually mean, what physical properties. I look at my pen, okay? I see properties, okay? I feel it. I know that it's pretty hard, right? I know that it's pretty shiny. It would have a, we call that luster in chemistry. Let's see, what else? I know that it's black, okay? These are all physical properties. If I put this in a really hot stove, I have a feeling it would melt. I think that this probably would have a low boiling point. So we're going to kind of look at those things. So the periodic table, you guys know that. Organized, we're going to kind of go a level deeper today in how and why it is organized the way it is. What actually is an element? A review. It's the simplest substance that exists. It's kind of weird. I think it's really weird. It's also really cool. It's why I love science. You looking at your periodic table right now, like all 118 elements make up everything you've ever seen and interacted with. So it's a simple substance. It's only made up of one kind of atom. It cannot be broken down into anything simpler. So we're going to talk about properties today. This is going to be kind of heavy vocab. Looking at my note sheet right now. So the words are luster, malleable, ductile, hardness, conductivity, melting point, and boiling point. Some of those might be new words. Some of them are going to be review. Like you guys know boiling point, you know melting point. We'll talk a little bit about density. But we are going to use these terms frequently. So when you come back to class, if you're watching this on Tuesday at home or Wednesday at home, I'm going to have these kind of properties. We're going to be studying properties for the next couple weeks. Or next couple days, excuse me. So I want us to familiarize ourselves with these terms. All right, getting into these actual properties. The first one we're talking about is luster, and it's a fancy way to say shiny. And I would sing the Moana song, well, especially into my elite mic, but I told you I'm trying not to ramble. So it's just the way light reacts to it. So the opposite of shiny is dull. So elements that have a high luster would be very shiny. Elements that have a low luster would be dull. That's how that works. Second property we're talking about today is something known as malleability, whether something's malleable. So something that's malleable can be bent or hammered into sheets. Metals, for example, can be bent. A wire can be bent. It's malleable. I tried to make a cookie reference. That's why I redid this slide, because I was thinking, how about this? A chewy cookie is malleable. Something that's like really crunchy, something that I baked and is really burnt, that'd be brittle. So the opposite of malleable is brittle. Brittle meaning it's going to break quite easily. Another property, ductibility or ductile. It's the ability to be made into a wire or drawn into a wire. It's pretty kind of straightforward there. Copper, for example, is a very, very, very common object or common element to be used in wire making, wires, because it's very ductile. Or you could say ductile? Ductile, ductile, I don't know. I'm your teacher. I should know that. Another property, pretty darn cut and dry. This would be hardness. So we have a diamond. That's one of the hardest substances on our planet, and it's just that simple. As how hard is it? So by definition, the measurement of the difficulty to shatter or crush. Some elements are going to be harder than others, and we're kind of placed in specific groups or periods of the periodic table based on that. Another property is conductivity. Fancy way to say, can electricity and heat pass through it? So think of your pots and pans. Those have, well, one, they're made out of metals because metals are more conductive than non-metals. If you had a, I don't know, I'm looking at my kitchen, which is why I'm looking over here. If you had a pot and pan made out of sulfur, I don't think that would be very good for conductivity. And you also know, like again, I'm looking at my kitchen over there, cast iron. I have an iron pot that has a different conductivity level than, I don't know, a copper pot. So it's again the fancy way to say, does heat or electrons or electricity pass through it easily? Moving into the melting point. Again, quite pretty cut and dry. It's the temperature when a solid turns into a liquid. All elements are going to have kind of different numbers of their melting point, and again are organized on that periodic table in a specific way due to that. Well, the friend of melting point, of course, is going to be boiling point. The temperature, you can't see me, but it's the temperature when a liquid turns to gas through heating. You can fill that in on your notes there, fill it in there. But yeah, so when it's going to boil, when it's simply going to go from a liquid state into a gaseous state. Now, this is kind of weird to think about. I remember sitting back in chemistry when I was in school going like, well, why do I care about the boiling point of like iron or something like that? Well, you got to understand that eventually when it gets hot enough, even metals are going to turn from a liquid, and well, obviously from a solid to a liquid and then to a gas. And that is super, super, super important when we're like making materials, building materials especially. We want something that has can withstand the heat, and obviously different metals can withstand different amounts of heat. We are going to draw in class either Tuesday or Wednesday, so you may be watching this before you've done this. So I don't want you to draw on your color periodic table if you're at home yet. We'll do it in class. But we can classify everything on this into the periodic table as metals, nonmetals, or metalloids. And remember, we drew the staircase on the first day, and we said metals are this way, nonmetals are this way. Well, there's also these kind of funny metalloids that are chilling on that staircase, and they're quite special because they have properties of both metals and nonmetals. So we're going to explore them a little bit. Cool. First off, we got these wonderful things known as metals. You guys don't need me to sit here and explain to you what a metal is. But I will say they are always going to be on the left side of the periodic table. Most metals are solid at room temperature. There's a very special one, element number 80, that's actually liquid at room temperature. Remember, we played with gallium. Gallium's over here. It is a metal, but you saw that has a super low melting point. Its melting point was like 85 degrees Fahrenheit. So we know that those properties all change, but most are metals. Most metals are solid at room temperature, and they're on the left side of the periodic table. They're going to have metals, not they. They're going to have a shiny luster. They're going to be ductile. They're going to be malleable. So if I, in class Thursday and Friday, we're going to examine these different materials, and we're going to kind of gauge, well, is it shiny? Does it, like, what's its luster level? Is it ductile? Is it malleable? Can we bend it into sheets? And we're then going to classify our elements based on that. Metals are usually going to have a super high melting point. They're going to have a very high density. They're also going to be great conductors of heat. I was talking about kitchen equipment earlier. That's why your kitchen equipment is metal, because it conducts heat. That's also why we need to use a pot holder when we grab that hot cookie tray out of the oven, because that material is a good insulator. Metals, we know, are great at holding heat and allow electricity to pass through it. So again, if it conducts heat well, it usually conducts electricity well. So we'd also say that metals are good conductors of electricity. They also have this thing, and it's super annoying in the winter, is they have a chemical, they react well with water and oxygen. and that is what causes rust, corrosion, and the salt, obviously right now, is not doing any favors to our vehicles as well. Now the special ones, metalloids, germanium, silicon, polonium, arsenic. There's really not that many. So we're going to kind of examine what the heck is going on with these metalloids. They are on the zigzag line. They can be clustered around the dark zigzag line, and I believe you can see that. I know my head's in the way. And they are kind of, why are they called metalloids? Well, because they're kind of like a hybrid between a metal and a non-metal. I think it is a cool name. They have metal-like properties and also non-metal-like properties. Some are shiny, some are dull. So remember, if it's shiny, that word is luster today. That's a fun name to say. Antimony. They're going to conduct heat and electricity, but not as well as metal. So if you're thinking, hey, I want to make a wire, well, I'm going to choose a metal and not a metalloid. And they can also be both malleable and ductile. Okay, and lastly, nonmetals. Finishing up here. These are going to... Talking about our friends, the nonmetals, these guys are going to be on the right side of the zigzag line. There's one little exception with the nonmetals, and I'll click the slide so you can see it. Hydrogen. Remember how there was an outlier when we did our alien sort, and this guy is sort of like the alkali earth metals, but not really. It would be a non-metal, so it really sort of belongs over here, but it sits in group 1. You can't see it right now, but most of these non-metals, and I'll get myself out of here, are gases. So most of these are gases, nitrogen, oxygen, and then neon, helium, argon, all very popular. I'm famous. I don't know how else to say it. You've all heard of them, but those are going to be gases. Many nonmetals are gases at room temperature, as I just said. They're going to have a dull luster. They're not going to be very shiny. So again, the opposite of dull would be shiny in this chemistry sense. They're going to be brittle. Remember, the opposite of brittle would be malleable, just to kind of get you to use these words. They're going to break really easily. If I was going to bend it, and I wanted to make it a wire, it would crumble in my hands. Think of like charcoal, which is mostly carbon. If you've ever touched it, it's going to get your hands really dirty. If you wanted to break it in half, it would crumble and break into a million pieces. They're going to have a super low density. And lastly, our friends, the nonmetals, they're going to have a low melting point, which makes them poor conductors of heat and electricity. Okay, we're finished. Think about what you just did. We looked at the 3 types of elements on the periodic table. We have metals, we have nonmetals, we have metalloids. We talked about the properties that metals have. Okay, and I'm reading them right off my list right now. When we look at something, we look at an element, we're going to kind of grade it on different categories. It's luster, it's malleability, is it ductile, how hard is it, what's its conductivity, melting point, boiling point. All of those things go a level deeper into the periodic table. That is why I'm sitting here telling you that, okay, I look at this, I look at mercury, I know that it's a metal, but oh, it's unique, it's liquid at room temperature. Okay, silver, gold, copper, well, they're all similar conductivity, they all are very dense, they all have very high melting points. Kind of makes sense. All right, you finished. Thank you for spending 14 minutes with me today. Secret assignment for the day after you've watched this and you're like, Mr. Murphy, is he really going to keep rambling? But you're so excited because you get the opportunity to learn today, and we love to learn because it's the best thing in the world. Would you message me your favorite color? Yeah, that sounds good. Okay, favorite color, crystal clear microphone. See ya.